Assalamualaikum and hi, my name is BINTI with number matrix 07DM23F1020.
Nama saya Muhammad Abzan bin Ramli, nombor matriks 07DM23F1026. Selamat pagi, Assalamualaikum. Introduction. This project focus on a mobile robot with obstacle avoidance and autonomous robot designed to navigate in environment safely by detecting and avoiding obstacles in real time. Using a microcontroller as its brain along with ultrasonic and infrared sensor, the robot processes incoming data and control its motor to move efficiently without collision. This system demonstrates the practical application of embedded system in robotics, highlighting the integration of sensor, actuator, and real-time control of autonomous operation.
So the description of our mobile robot. So the mobile robot is designed to move autonomously in its environment while continuously detecting and avoiding obstacles. It uses an embedded system to integrate its sensors, microcontroller, and actuators without human intervention. The robot can navigate around static or moving obstacles. It will adjust its path dynamically and maintain continuous motion. It will demonstrating practical application of robotics and real-time embedded control. So this system highlights how sensor inputs, microcontroller processing, and motor control work together to create an intelligent, autonomous mobile platform.
Next, key components. The main component of the system are first microcontroller ESP32, which is the brain processing data from sensor. Next, sensors such as ultrasonic and infrared, which detect object and measure distance.
For the next key components that we use, the next one is actuators. For example, DC motors that controlled by a motor drive that execute movement commands. The next one is power source, a rechargeable battery that powers the entire system.
Next, system operation. This slide shows how the robot operates step by step. First, sensor detect obstacles and measure the distance. The microcontroller then process the information and decide how to move, whether the slow down, stop, or turn. Next, the motor driver receive task command and control the wheels to execute the movement. This allows the robot to move safely around obstacles, maintaining continuous motion.
For our real-time aspect, I will give an example, a chair. So imagine a chair suddenly appears in front of the robot. The sensor immediately detects the obstacle and send data to the microcontroller. Within millisecond, the microcontroller calculates a safe path and instructs the motor driver to adjust the wheel motion. The robot will turn or changes direction instantly to avoid a collision. This process repeats continuously, forming a real-time feedback loop, and meaning that the robot is always aware of its environment and reacts instantly to any change.
Importance. Explanation. The importance of this system can be seen the three main aspects: safety, efficiency, and reliability. First, safety. The robot instant reach to obstacles, preventing collision with objective, furniture, and people. This helps protect both the robot and its surroundings. Next, efficiency. The robot moves smoothly without unnecessary stop or reversals, saving time and energy while completing tasks faster. Next, reliability. The system responds consistently in dynamic environment, ensures stable and predictable operation even when obstacles move or appear suddenly. Overall, these three aspects, safety, efficiency, and reliability, are what make the obstacle avoidance system a strong foundation for modern autonomous robotics.
So this is our block diagram that link to the real-time process. So the first one, when an obstacle appears, that is a chair, the sensor will detect it and measure the distance. So that distance data is sent to the microcontroller, which then processes the data and make a decision, for example, to turn left or right. And then the motor driver receives the command so that the motor can adjust the wheel motion. And finally, the robot will avoid the obstacle in real time.
In conclusion, the mobile robot with obstacle avoidance serves as a practical demonstration of embedded system integration, where real-time response enables safe, efficient, and reliable autonomous movement. By combining microcontroller programming, sensor integration, and actuator control, the system highlights the seamless integration between hardware and software. This makes it a valuable tool for robotic education, industrial automation, and the development of smart device, showcasing the capabilities and benefit of modern embedded system in real world application.